Recording in progress, you heard. So let's start with our wonderful meetup. Welcome everyone to our April meetup. And this wonderful year, 2021. What we have today for you in place. At first, we have Slido, which you can use later on for your questionnaire. If you don't want to do it publicly, you can also do it anonymously there. Just scan the QR code with your phone or go to the website or use the code directly at slido.com. You can also see it always, all the time during the presentation at the bottom. And then we can show later to you the questions you have, if you have any. So today, thanks for Matso. Don't get me wrong, but I probably don't pronounce it properly at your last name, so I don't do it. Abgaryan. Let's see. Nevertheless, he wanted to show us something, how we can adapt clean architecture in our Android app and how we can use it as Android developers for better applications for the future. Like I said, that's a Slido one, and I would hand over directly to Matso.
Thank you, Hassan. Hello, everyone. So first, let me share my screen, please. You see my screen, right? Perfect.
Yes.
So as Hassan introduced, I'm Matso Abgaryan. And not a surprise, I'm a standard engineer from Obneo. And today I will present how to adopt clean architecture in Android apps. So let's get started. So my talk will be in two parts. In the first part, I will talk about more clean architecture. Why should one use clean architecture? What is the clean architecture? The characteristics and the layers of the clean architecture, and some design and component principles of the clean architecture. And then in the second part, I will talk about how to adapt the clean architecture with practical steps into Android projects. So first, how to organize modules in Android projects, and then how to create layers in Android projects in clean way. In short, I will adapt the clean I will show how to adapt clean architecture in a Android project. And finally, I will go and talk about the key important points of the presentation at the end. So let's get started. First, let's define what is architecture. It can be defined in many ways. So architecture is the shape of the system. The architecture supports the behavior of the system while keeping its flexibility to change. All architectures have one common goal: to manage the complexity of our application, right? So we may not need to worry about this, about having architecture for smaller projects or pet projects, but it's lifesaver for the medium or bigger complexity applications. So before defining what is clean architecture, let's take a look why should one use a clean architecture. So it's testable. It's really easy to follow any kind of testing strategy, or testing pyramida or TDD, any other strategy, independent of the data sources. So every data source is just a data provider, and an application has real use cases instead of being a crude system. And then it comes frameworks and libraries. So frameworks and libraries are isolated in individual modules, so that when we change one thing in some place, it won't affect all over the application. It will be changed only in this module. And finally, independent of UI. So all business logic is in use cases, so it's easy to find and remove the duplicated logic. And also it has a screaming architecture. It means like it shows what is the architecture, what app does, instead of getting lost in the details when we are browsing for the project. So what is a clean architecture? The clean architecture was proposed and introduced by Uncle Bob, or as known as Robert Martin. So clean architecture separates the application code into the layers and these layers define the separation of constructs inside the code base. The overriding rule that makes this application work are the dependency rule and the abstraction rule. So on the next slides, I will explain what are these rules. So let's see what are the characteristics of the clean architecture. The cycles represent different levels of software in the app. And there are two things I would like to note that I mentioned before. The first thing is about abstraction principle. So the center cycle is the most abstract, which doesn't rely on any platform or framework we are using. And the outer cycle is the most concrete. So this is the abstraction principle. The abstraction principle specifies that inner cycle should contain business logic and the outer cycle should contain the implementation details. Another principle that I mentioned is the dependency rule. So this rule specifies that each cycle can depend only on the nearest invert cycle. This is what makes all the architecture work. And further, let's take a look at the layers in this picture. So let's start with the enterprise business rules. There we have entities. So entities summarize the enterprise-wide business rules. An entity can be an object with methods, or it can be a set of data structures or functions. It doesn't matter as long as these entities could be used many different applications in the enterprise. But if we don't have an enterprise, we have only one single application, then these entities are the business objects of the application. So they encapsulate the most general high-level rules, and they are least likely to change when something external changes. Let's say testing framework or database framework or image loading library. And then comes the application business rule. There we have the use cases. So software in this layer contains application-specific business rules. It summarizes and implements all of the use cases of the system. These use cases manage the flow of the data to and from entities, and those entities use their enterprise-wide business rules. So whenever we change something in our application functionality, we accept something change in this layer. Otherwise, any other changes don't affect in this layer. And next comes the interface adapters. So the software in this layer is a set of adapters that converts the data from the format most convenient to use cases and entities to the format most convenient to external agencies such as database, web, or any kind of other frameworks. So the presenters and controllers are all belong here. The modules are likely, sorry, I need some water. So the models are likely to just data structures that are passed from the controllers to the use cases and then back from the use cases to the presenters and views. Similarly, the data is converted in this layer from most convenient for entities and use cases, and vice versa into a most convenient whatever framework we use for persistence or database. And next comes the framework and drivers. The outmost layer is generally composed of the frameworks, tools such as web frameworks or external interfaces. This is in this layer where all details go. So the web is a detail, the database is a detail. So we keep these things on the outside where they can do little harm. And so one might ask only 4 cycles. The answer is no. These 4 cycles are just representative. Sometimes they could be more or sometimes could be less. In the later example, in our case, adapting to Android, I will show that it's different, it's not 4. So there is no rule that says this cycle should be only 4. So as soon as we are keeping the dependency rule, applying dependency rule and abstraction rule, it's fine. Another interesting question is what kind of data crosses the boundaries between these layers. So typically, the data that crosses between the boundaries of these layers are simple data structures, like it can be transfer objects or any kind of models. Again, the important thing is that is the data model should be isolated. So we don't want to cheat and pass a data model with database annotation or any kind of JSON parsing annotation to the, let's say, use cases or entities. They don't need to know about this. It's supposed to be clean. Okay, next, let's take a look. What are the solid principles? I'm pretty sure vast majority of you know this, but please bear with me. I would like to present because it's one of the pillar principles for clean architecture. So let's get started. The solid principles are the acronym for 5 design principles: single responsibility principle, then comes open closed principle, least cost substitution principle, interface aggregation, and dependency inversion principle. So let's take a look deeper each of these principles. First, let's start. What is a single responsibility principle? A class should have only one reason to change. To put it more simply, it means that one class should only have one responsibility, right? So for instance, let's take this example. This is a bad example because it violates this principle. In this example, the onByte method is responsible for mapping the model, in this case a trip model, into the view. But as you can see, it does also some other thing. It does formatting, which is the violation of this principle. Next, let's see how we can improve this. And now, as you can see, the part of doing the formatting is extracted to that So onByte method is now responsible for only one thing, to map the trip into the view. And next comes the open close principle. So software entities such as classes, functions, or modules should be open for extension, but not for modification. Again, to put it more simply, it means that if you are required to add a new feature in a project, it's good practice to not modify the existing code, but rather write new code that will be used by the existing code. Again, it's too theoretical. Let's take an example, right? So we have a time greeting class which takes the time of the day and supposed to return greeting when we call this greet from the time of the day function. But as you can see, this is not scalable. Whenever we add another time, then pass another time, then we need to every time modify this greeting from the time of the day message, which is a violation of this principle. So let's see how we could improve this. So we could create an interface called time. It will have this function called greets, and every time that we pass to our time greeting class should implement this interface. And in the time of the days, they will return the greet message usual to them. So the time greeting class doesn't have to know anything about this this message. So whenever we pass time to time greeting and call this get from the time of the day, it will return this time specific message. So as you can see, it's pretty scalable. We can create a different times of the day and pass to this class. Yeah, and next comes a least cost substitution principle. So child classes should never break the parent class type definitions, right? To put it more simply, it means that subclass should override the methods from the parent class that does not break the functionality of the parent class. So again, this is a bad example. We have a rectangle class here, and then we have a square class which inherits from rectangle. And as you can see in this noted areas, they break the parent's definition. So whenever we set width, it overrides the height, and vice versa for the height. So again, let's see how we could improve this by applying this principle. And yeah, so when we create a rectangle, set height, width, and then call get area. So what do you think? What will be the result of the rectangle get area? Just a question. Yeah, never mind. So it would be 25 because it takes the last value from the set height. Again, this is a good example. What we do, we create an interface called shape, where we have this behavior for get area, and every other classes, they implement the shape interface, and then they override the get area and implement the specific to their shape. So next comes this interface segregation principle. This principle states that no client should be forced to depend on methods if they does not to use. So every time when I am talking about this principle, I remember the interfaces for edit text field in Android all times. You have to override many functions to be able to use one. So again, this is the bad example. We have an interface that contains two methods, and then we have two other classes, buttons, let's say. As you can see in the noted area, these buttons, they don't really need these functions to override, but because it's inside the interface, they have to do it, right? So for that reason, let's see how we can improve it. We separate this interface into different interfaces, and then each button respectively will implement the interface that the method they are going to use. And next comes the dependency inversion principle. So high-level modules should not depend on the low-level modules. Both should depend on abstraction. Abstractions should not depend upon details. Details should depend on abstractions. Yeah, again, it's really academic definition. To put it more simply, it means if you use a class inside another class, this class will be dependent on the class that is injected. This is one of the main reasons we use dependency injection in our application development. And again, this is a bad example. We have a message board. Whenever we call print message, it's supposed to print the message from the given message. In this case, we have WhatsApp message. As you can see, this is not really scalable because whenever, let's say we want to add a Facebook message, right? And then we have to modify this print message because we don't really know what are the details of Facebook message. Let's see how we could improve this. So the way to improve this is we could create a interface for message. I call it iMessage to make Apple people happy. And then we have a WhatsApp message, and that implements this interface. Facebook message implements this interface. So there we will do the details, what kind of message to print. In the message board, whenever we need to print message, we will just call message, print message. We don't care, is it Facebook message, is it WhatsApp message? So it's independent, they are not coupled. And next point is about the component principle. So the components are units of deployment, the smallest entities that can be deployed as a part of the system. To put it more simply, it could be any kind of module that we are using in our application, or any kind of SDK, or even jar files. So there are three component principles: the reuse release equivalence principles, the command closure principle, and command reuse principle. I know these names are horrible, hard to remember even for me, but the important thing is to understand how they work. So first, let's see what is the reuse release equivalence principle. The granularity of the reuse is the granularity of the release. Again, it's a bit academic. The basic idea of this principle is that components must be separated, released separately, versioned and tracked to ensure the reusability of the code. If we don't have any version code or versioning or version name, it would be really difficult to track the compatibility of these components. So one must organize the classes into reusable components and then track them with the release. And next comes the command closure principle. So gather into components those classes that change for the same reason at the same times. So as you can see, this is a single responsibility principle that I mentioned before, like restated for the components. So this principle tells us which classes should be grouped together. So reusable classes are more likely to depend on each other. So classes are really reused in separation. This is important because if the code change, it is better that all of the changes occur in one component rather than in distributed in different components. So in that way, changes are confined to a single component. Then we need to redeploy only one changed component. So we don't have to deploy different components. And next comes the command closure principle. So don't force users of the component to depend on the things they don't need. Again, this is an interface segregation principle restated for the components. So this component helps us by telling we shouldn't force our clients to depend on things that they are not going to use, right? So this CRP tells us more about which classes shouldn't be together and then about which classes should be together. So in summary, the reuse release equivalence principle is about grouping things. The command closure principle is about grouping to increase the maintainability. And finally, the closure reuse principle tells us how to divide things to only depend on what you need. So there is this very interesting thing called the tension diagram between these three principles. It's like a triangle formed by these principles. This diagram shows that these three principles interact with each other, and difficulty is to place your component inside this triangle. So this is the ideal case that we want to put our component inside this triangle. So let's see why. The REP and CCP are inclusive principles, so they tend to make the component larger. And the CRP is an exclusive principle, so it tends to make smaller the component. And the tension between these principles are that good architects seek to resolve, right? As you can see, the edges of this triangle describe the costs of abandoning the principle of the opposite vertex. Again, an architect who focuses on just REP and CRP principles will find that many components are impacted when simple changes are made. So in contrast, an architect who focuses on too strongly to this CCP and REP will cause too many unneeded releases to be generated. Uncle Bob advises to focus on us to focus on the CCP and rather than REP principle in early stages of the development, because the development agility is more important than the reuse. So I covered the first part. Some footer. Next, I will finally talk about how to adapt this clean architecture in Android with a bit practical steps. So let's get started. As I mentioned before, the layers in clean architecture are not defined. You can take any kind of number of layers you want. In this case, we would need 3 layers: domain layer, data layer, and presentation layer. And before taking a deeper look onto these layers in Android project, let's first take a look at how to organize modules in clean way. So I consider code package organization one of the factors of good architecture, right? Because package structure is the very first thing when someone browses the source code, and everything flows from it, everything depends on it. You could divide up your application into packages in many ways, but I would like to discuss in 2 ways, right? So as you can see, this first way, package by layer, each package contains items that usually are not closely related to each other, but they're in the same layer. So this results in packages with low cohesion and low modularity, and high coupling between packages. As a result, editing a feature involves like touching all these modules or packages. In addition, if you want to delete a feature, you could never do it inside the one package. You will have to attach in different packages. And then there is another way, package by feature. It uses packages to reflect the feature set. So it tries to place all the related to a single feature into a single package. So this results in packages with high cohesion, high modularity, and minimal coupling between these packages. So items that work closely together are placed next to each other. So they're not spread all over the application. My recommendation would be to go packages by feature, which brings, I think, three benefits. So high modularity, easier code navigation, and minimized scope. And so it's worth to note that if you are working with the company with feature teams, and it's really easy to have a package by features because the code ownership is getting easier, and it would save you a lot of time and conflicts when you are merging your PRs, pull requests. And then for a specific case, next slides, I will present this feature login module in detail. So let's start with domain layer. There we have use cases, entities, and interactors. So in domain layer, we would need for this. This is only about this login feature, right? In this layer, we would need success, result, entity, which has success and failure, and returns type of T. It's kind of generic. And then we would need a user, domain-specific user object with the display name and ID. And then we need use cases, right? And obviously, we need some base use case. In this case, it takes type params and returns result type. And for this specific case, login use case, we would need a login use case, which depends on login repository. So whenever we want to log in, we call this use case, give the login params, pass the login params, and get the result user. And next in this layer comes the repository abstraction. It's important, abstraction, not implementation. And then we would need as well as the interactors. So interactors actually needed when we have, let's say, to group many use cases together to avoid having fat instructor for view models, or even we can have some logic inside the interactors, again, to make the view model a bit simple or readable, keep it small. Next there comes data layer, where we have data sources, mappers, and repository implementations. So we would need a user mapper interface that converts the data layer specific logged in user to user object. And then we would need the implementation. So it takes logged in user and does the mapping to user, domain layer specific user object. And we would need a data source. For this specific case, we have a login data source. This is just a dummy data source that returns dummy logged in user object just for this case. And we would need a repository implementation. So it's supposed to need a data source, user mapper, and type of login repository defined in the domain logic. Why? Because we want to hide this implementation detail from the presentation layer. So we will see later. So then we have this login function. When we try to log in the user by using a data source, if it's successful, fine. Then we would need to map the data layer specific logged in user to a domain layer specific user, and then return result success. Otherwise, if something goes wrong, we will return a result failure. And yeah, finally, let's jump into the presentation layer. So here we have view models, fragments, activities, views or dialogues, anything related to the view and the UI. So let's start with the view state. So for this specific case, again, we would need a view state object for keeping the state of the view. In the view state, we would need login form state, which states the form state for input fields, and the login result. If we tried to log in, what was the result, success or failure? And then, of course, finally, we would need a login view model, which needs login interactors. And then we would need some kind of way to keep the state. In this case, I use the mutable state flow, or you could use live data. It doesn't really matter. With the initials, the cool thing about the state flow is that you can pass the initial state. And we would need the login function. So whenever a user tries to log in, it will call login view model login by passing the parameters, and we will launch coroutine via login interactors and use case, and we get the result by passing the params. So we'll get the result, and depends on the result. If it's successful or not, we will map it to a view state that we saw before. And then we will pass this new view state to the mutable state flow, that later on, when the fragment that consuming this state flow will update the UI accordingly. And here it comes, the fragment. So we have a login fragment. Again, it's like I try to make it as coincident as possible and make it readable. And so here we have on view created function already done, right? And here we collect the latest state of the state flow. We pass the lifecycle scope and then function called collect view state. And whenever the state is changed, the collect view state function will be called. And inside this function, we would have a view state, and depends on the state. If it's error or success, we would show login failed or update UI with user. So to show the user display name. So yeah, this is about the presentation layer. And the next thing I would like to talk about is the data flow between these layers. So as you remember, we have a presentation layer, domain layer, and data layer. So let's say user clicks on login, input fields, and let's see how the data flows. From login fragment, we call to login view model, and from view model, via login interactors, the data flows to use case, and then from the use case, it has dependencies to login repository and result. We call login repository implementation, which which calls login data source, and if the result is successful, not failed, it would need a user mapper to map this data layer specific user model into domain layer specific model. And then the data flows back to use cases via interactors to model. And then when we have this new result into view model, it will update the view state. And whenever the view state is updated, the login fragment will update the UI accordingly. So yeah, this is how the data flows between the layers. So it's worth to mention that domain layer is kind of glue layer between this presentation and data layer. And data layer shouldn't know anything about the presentation layer, and presentation layer shouldn't know anything about the details, anything about this data layer. So next, let's see what are the pros and cons for clean architecture. So it's testable, as I said. We can easily follow any kind of testing strategy, testing Pyramida or TDD, independent of the data sources. Independent of the data sources. So it doesn't matter for the presentation layer really that what kind of data source we use. We can replace them easily, and vice versa. And independent of libraries and frameworks, so they are isolated. Whenever we change any kind of library in one module, it shouldn't affect to others. All the business logics independent of UI. So all the business logic is in use cases, so it's easy to find and avoid duplication. And finally, it's like a screaming architecture, right? It's really easy when you browse the source code, if it's implemented in a clean way, to understand what the project is about, rather than getting lost in the technical details. and cons, many ways to implement this. We need some, because of the abstractions, we need a lot of boilerplate code. And sometimes for the smaller projects, it's like overkill, not really recommended. And it might require also some learning curve to understand like how these layers fit together properly without violating this dependency rule and abstraction rule that I mentioned before. So I would like to end with the summary of the main points. So I talked about what is the clean architecture, the layers of the clean architecture. From the beginning, it was 4-layer. And then I talked about the solid design principles and then component principles, the tension diagram between principles, and are those good to use together or not, depends on the use case. And then clean architecture layers in Android. In Android, I use 3 layers: domain, data, and presentation layer. And then finally, we discussed how to organize modules in Android in a clean way, kind of. So I would recommend to go by feature. And we discussed I showed the data flow between the layers. So the domain layer is the glue between presentation layer and the data layer, and they don't know really about each other. I think that's it. If you have any questions.
I think we have some questions on Slido. I just take over or just ask the question.
Yes,
thank you very much, Matso. So the first question is, will you publish the slides?
I will, yes.
That's wonderful. Next one from an anonymous person.
Oops,
how do you handle common model service and multiple features?
So it depends, right? For example, we have mostly common layer for like networking and modules, or sometimes for UI. But basically the future modules are kind of depend on the common layers. Yeah, this is how we organized in our project. I hope it helped. I answered the question.
I don't know who was the anonymous person that answered the question. I think you can open your mic. Not, it's fine, I think. Otherwise, you can send another anonymous question if it doesn't answer your question. Next one, how often do you review the chosen architecture to see how many wrong assumptions you made?
It's really a good question. I would say I'm keeping a track what changes are in the community. But of course, as I mentioned, the clean architecture, like you can implement in many ways. It's not written on a stone. The only good thing I think about the clean architecture is it's really flexible. The important thing is to, as I mentioned before, have these dependency rules, right? Abstraction rule and the dependency rule. We have to apply them.
Okay, that answered one question. There comes a new one. Okay, I can answer the question regarding the sharing the slides. I guess it will be definitely over meetup.com, Twitter, as well as our Slack, I guess. So yeah. There will be slides definitely, and you will get it on one of our official channels.
I have a small question regarding the domain model to like the mapping. Would you always use a mapper, like a separate class, or like an Android specific, like do some extensions, or?
So yeah, I always tend to do a mapping. It depends, but to be honest, it depends. But mostly I try to use mapper. I know actually before in our company, we had kind of like counter arguments. It's like overkill and blah blah blah. And then we had a merger, and finally we figured out that actually it was like really time saver. So sometimes you never know, right, what will happen for the future project. And then if their times come, it's really easy when you have this kind of mappers or separation.
Okay. Yeah. And again, when did you realize it was good to have a mapper, or you wanted one? Can you
No, in
elaborate?
general, I like mapper first. There are two reasons, right, for the mapper. First, we want to have different model. If we want to have a different model, we could go other way. We could have extension functions. But the problem with the extension functions are that then it's tricky to test them, right? If you have a mapper, you can just create a mocked version of your mapper and return mock data, so you don't have to go to the details of these extension functions to mock them. Yeah. But if you decide, okay, you want to have the same model for domain layer, for data layer, like one model, then in this case, I think you don't need mapper.
I'm trying to think when I wanted to mock the mapper. I mean, I would have simple data models, and then they would result in domain models and mapped. Yeah, hadn't crossed my mind or path yet. I wanted to mock a mapper.
Yeah.
I have a different question, which somehow plays a bit more also in that boilerplate code, which you have. I'm personally for the mapper, but not as a class or just as an extension function, and don't mock it in test classes because you test the obvious things. My real question is something different. It was more about why you always have an interface. I know from clean code and all these clean code books or whatever you call it, these wonderful books, always they say do interfaces. To be honest, in my career since 20 years, I nearly didn't need any interface where you just have one and one only implementation.
Yeah. So first about the mapper testing the mapper. What I meant is not testing the mapper. So you would need to test the use case, and inside the use case, you are doing the mapping, right? In that case, you kind of need to mock the mapper. That was the point, not testing the mapper implementation.
That's contrary. Sorry, just to jump in there. In contrary, I would test the mapper. So that's even the extension function you can test. But the point is, in the use case itself, I wouldn't test mock the mapper because you did a lot of boilerplate code for the mocking, where you know the result should be what you expect because the mapper does what you want at the translation of the object.
Yeah.
The mocking, you just fake something which is probably not there. You don't test the thing that you have created there.
Yeah, because you don't care about the mapper, you care what it returns, right? In case of the interfaces, again, why I really like the interfaces, because of the testing, right? And dependency injections. So if you never use the interfaces, I'm wondering how did you do the dependency injection or
you can
testing?
do dependency injection without any interface.
Yeah. That could be.
That's what I'm meaning. The point is, it's not about, I do always dependency injection and all that stuff and also testing it. But the point is, you don't need an interface nowadays for that. I know previously you always had to use one, but nowadays you can go on and use everything without an interface where you don't need it. For example, the things that you showed was a message. That makes totally sense to use an interface. But not for a repository where you have just one implementation.
Yeah, it was just an example to show. Maybe it was a bit bad example.
Not about bad example. It's not something I see it often, even by a lot of engineers, that they say we have to have an interface for the sake of having an interface. And I think you should probably think over it a little bit, because that's really a lot of boilerplate code which you probably never need again.
Yeah, that's a downside, right?
Yes. But nevertheless, thank you for your presentation.
Sure. Oh, and one more thing, if there is no any questions. So in our company at Mobimeo, we are hiring. If you are looking for a job, please scan this QR code. You can find more about the details of the position and the company, and finally you can apply it. that's it.
1 second, there was another question.
Yes.
Are there any GitHub samples from the things that you shared us?
Yes, I have some GitHub samples I will share lately.
Okay, thank you. And there's another question. Okay, we can discuss this probably later on about the interface thing.
Yeah, even some people actually,
Mm.
especially from a functional programming community, they are not really happy about the clean architecture, some parts of it. But I would say there are many ways, right, to solve the problem. So I'm not saying that clean architecture is the best one. There are so many architectures you could use. Just trying to present one of them. So
I agree. I think I just take over the presentation.
yes, I will stop sharing now.
Thank you, Matso.
Yeah, again, thanks. And now just come to my wonderful slides back. Flea market. I know everyone loves this wonderful flea market and want to say something to the community. So is there anyone want to say about something about the flea market or for a job? I know Mobimio does. So if you want to work with Matso and with Mario, don't hesitate to contact them. Anyone else? No one?
If we want to socialize in a different space later, here's a link that I set up. You walk in a 2-dimensional space, and when you get close to people, you can talk to them. If that qualifies for a flea market.
It's definitely, I think we can try that afterwards as some more fun part. So no one flea market. That's fine. If not, you can always use our Slack if you have any questions, programming wise, or however we can help you there. Then we definitely need some more speakers. Matso was one of the newest member of our speakers in this round. I think it was also his first one in the community, or am I wrong, Matso?
Yes, for the community, yes.
Yeah. So if you want to be like him, want to challenge yourself to do something interesting and something new for yourself, don't hesitate to send a proposal to our talk@berlindroid.de, and then we try to contact you as soon as possible, but it's definitely not the same day probably. So we can see if we can manage to get you in. But definitely I can say I think the queue is currently quite empty. So if you want something present, don't hesitate to send us. Next slide will be, well, our next meeting is on the 26th of May. I think I will stop now the session so we can do some open questioning if there's something. So I stopped the recording. Let's see where it saves the recording. Nevertheless, I stopped, I thought, no.